When we look at symmetry, we are trying to determine whether a graph is the same on both sides of the x-axis. So this is our x-axis. This is our y-axis. If something is symmetric about x, it's the exact same on both sides of the x-axis. Like a graph that looks like that is exactly the same on both sides of the x. If it's symmetric about the y, it's exactly the same on both sides of the y-axis, something like that. If it's symmetric about the origin, it would be exactly the same around the origin. Now what you're going to be doing is you are going to be trying to determine symmetry algebraically. So if you're trying to determine whether something is symmetric with respect to the x-axis, you will replace all the y's, and remember that f of x is also the same as y. You will replace all the y's with negative y's. That's for symmetry about the x-axis. If you're trying to find symmetry around or with respect to the y-axis, you will replace all the x's with negative x's. If you're trying to determine symmetry about the origin, you will do both. You will replace the x's with negative x and the y's with negative y's. So the toughest hurdle that you'll have for doing any of these problems would be your algebra, because what you're going to do is you're going to make those replacements, and then you're going to do your algebra and try to manipulate the problem to see if it looks exactly as it did when you started. If it does, the symmetry is true. If it does not, there is no symmetry. So let me do an example with you. Let's pretend this is our problem. F of x equals x squared plus 2y. So when I look at this problem, really there are two y's in it. That one is a y, and this one is a y. So if I'm trying to determine symmetry with respect to the x-axis, I take this problem and I replace every y with negative y's, and I put those in parentheses so that I will get my signs right. If I take a negative y, since it's not squared or anything like that, it's still going to be a negative y. 2 times negative y is negative 2y. Remember from algebra that you can't have a negative on the outside of a variable, so we're going to take that and multiply that negative all the way through everything. And then we're going to compare it to what we started with. It is not the same as what we started with because of this negative that's on the outside. It's not being squared because it's on the outside of our variable. So this is not what we started with, so it is not symmetric about the x-axis, and you would simply say no because it's not symmetric. Now let's look at symmetry about the y-axis. So let's erase this one, and we'll start over. If you're trying to find symmetry about the y-axis, you substitute your x's with negative x's. So here's my problem. Here's my original one still. I'm going to take all the x's and make them negative. If I take a negative and I square it, see, it's inside parentheses, so if I square it, it becomes a positive. This is exactly what we started with originally. So this one is symmetric about the y-axis. So you would simply say yes. Now for the origin. So let's erase this one. Keep our original problem there so we can look at it when we do the origin. And for origin, we will substitute the y's and the x's. So I'm going to substitute this y. I'm going to substitute this x. Then we'll do our algebra. Remember I said this will be your hardest part because you'll have to remember what you've done in previous classes with negatives. what happens when you square a negative, what happens when you cube a negative. If you don't remember those things as you're doing the algebra, you need to go to academic support and get some help, or call me and ask me. A negative y that's not being squared or cubed or anything like that will just still be a negative y. Negative x squared will be a positive x squared. 2 times negative y is negative 2y. I can't have a negative on the outside, so I'm going to change that. And again, it is not the same as what we started with, so this one is not symmetric with respect to the origin.